Good afternoon, gentlemen. We'll start our boiler
Good
classes.
afternoon, sir.
Good afternoon. I'm sorry we got a little delayed because the internet signal had gone off completely. Even now, the internet signal is not very strong. So if you cannot hear me, please let me know immediately.
Okay, sir.
Right. So, any questions? We can start now. Hey, gentlemen, this is a question and answer session. So, if you have any questions, please come ahead. Okay, since you do not have a question, okay, let me start by asking a question. Is the same question what we were talking about last week about our thermal oil plant. So let me break the ice and then we can take it forward. Now, in our thermal oil, where did that? One sec. In our thermal oil plant, so this is your typical circuitry or rather layout or design of a thermal oil plant. So you have the heater, and here after that you have the heat exchanger, which is optional. Heat exchanger means you could have a boiler kind of thing which is heated to, which is heating the water, and the water may be being used for something else. Maybe the water is being used for steam or whatever. And then it goes and does the process. Now, last week we were talking about, and you gentlemen had told me that I think it was EOB or Tesfaun ship, there was a cooler fitted somewhere over here. If you follow my pointer, there was a cooler fitted somewhere over here. And the reason for the cooler was that the pump was not able to handle the temperature. So my question is, why don't we fit a pump which has got a higher temperature rating? Instead of cooling the thermal oil down and then raising the temperature again. Did you understand my question? Whose ship was that? Yep. Was that your ship?
Yeah.
You're coming quite broken. Since I'm not able to hear you, probably because the signal from his side also is quite weak. Yeah, we'll.
Yes, it was my ship.
Hello. Yeah. Okay. Yeah, it was your ship. So, did you understand my question? Well, if we were to design a thermal oil system, won't we try to put a higher temperature rating pump over here, a pump which has got a higher temperature rating, instead of putting a cooler and then cooling the oil down and then heating it up again? So that means we are burning extra fuel. Yes, Hail Selassie.
Jeff, I think it's like an optional. What I understand is it's like an optional, the cooler. For example, if the boiler at sea, we are using main engine exhaust gas.
Okay.
That means for example, in all of my contract, the exhaust passing through the boiler, there is no any bypass. Always it has to pass through the boiler.
Mm-hmm.
So sometimes we have a damping in steam. So the damping valve, so the steam will go to the cooler, the extra steam. But in the oil here, if the exhaust it has to pass through the thermal oil heater boiler, so we will have more than our capacity. We have more oil which we don't need. So at this moment, we need to cool it to circulate. So this cooler is like an optional.
Cooler is
That's what I understand.
cooler is off. Yeah, Helsala says that sounds that does sound logical. Yes, I would agree to your argument. Yes, it does sound pretty logical. That where out at sea, as you said, the temperature, because the boiler does not, the exhaust boiler does not have any bypass, so the oil is getting heated up, and we are not able to use all that heat. Correct. So then we cool it down.
Yes, that's my point.
That sounds logical. Yeah, yes, that is pretty acceptable. Sophonias, yeah, you had raised your hand. What was your question?
Okay, Chief. No, it's not a question. Answer for your question.
Yeah, please go ahead.
Uh, I agree with have to, but for his reply, I would say in this diagram we will see the outlet is already occupied with equipped with cooler, so it's not necessary to put it before the pump. But to come back to the original question, why we don't use a high capacity pump is because it was going to be expensive, and most probably the outlet, usually when we are using the full capacity of this system, the outlet will be cold, so the pump can work normally. But sometimes we may not use, maybe we don't have enough cargo to heat up or something, so the hot oil will be circulating back.
Correct.
During that time, the pump will be working in high temperature. So for that condition, to put a high heat capacity pump will be not making sense for the company. Yes.
Not
so
economical.
For that reason, we can put a cooler just in case we don't use the full capacity of the system, so that the pump can be in low temperature capacity.
Yeah, so Sophonias, that is also true. That could be one of the reasons. Okay, let's. Any other questions on any other topic? Yes, Yob. Go ahead.
Yes, Chief. Good afternoon.
Good
Can you
afternoon.
hear me now?
Now you're
On
coming
this expansion,
coming quite broken.
on this expansion tank, for what we need this vent, and what type of gas we are using on this expansion tank?
You mean for the thermal oil system?
Yes, on the thermal oil system, there is this expansion tank, and there is
The
the
expansion tank.
vent with side glass, and if there is vents, this means there should be gas inside. And what type of gas should be there?
The gas normally would be a thermal oil vapors. I presume from you're coming pretty broken, but I presume you're talking about the thermal oil system, correct? And you're talking about the expansion tank in this diagram. The expansion
Yes.
tank would be basically for makeup feed. As the thermal oil heats up, any extra thermal oil from the system, the thermal oil which expands, that goes there. Thermal oil cools down, it comes back, just like an expansion tank in any other fluid system. And the side glass would be normally would be made of your borosilicate or your silicate glass, which can withstand high temperature. But this is the expansion tank. We should remember, it is not part of the system. It is out of the system. Only thing there, I mean, out of the system, I mean, there is no in and out. It is just one inlet, the same inlet and the same outlet. That means as the thermal oil system starts, the oil starts heating up. The oil will expand. Any extra oil that will go to the expansion tank. When the thermal oil system starts cooling down, the oil from the expansion tank will come and form the makeup feed. That's all. So the expansion tank need not necessarily be, or rather, it will not be at the same temperature as your system.
Okay.
Does that answer your question, Yob?
Yes.
Any other questions? Yes, gentlemen. Any other questions? If you have any other questions, I'll try to answer that to the best of my ability. If I'm not able to answer that, I will find the answer for you and get back to you. So either way. We have a boiler class next week also. That is this coming week. And in that boiler class, in addition to the things which we have remaining, which is actually not much, I just wanted to go back to the boiler tube repair. I feel we did not cover that properly, and it is possible that you may have questions regarding this, especially in a water tube boiler, the tube repair and the plugging in a water tube and a smoke tube boiler. So in our coming class next week, I would like to touch upon that also. Time permitting, of course. We just have one boiler class remaining. So time permitting and of course internet permitting, we will. I'd like to just go upon the boiler tube repair also. But in the meantime, any questions, please. Okay, I've got one question for you. Why is a smoke tube, why is a sun-rod boiler known as a hybrid boiler? It is also a water tube boiler and it is also a smoke tube boiler. So since you gentlemen are not asking me questions, let me break the ice some more and ask you a question. Why is sun-rod boiler? I will repeat my question. Your Albog sun-rod boiler. Why is it considered to be a kind of hybrid boiler? Anyone? Would anyone like to answer that question? Yes, Sophonias.
Okay, thank you, Chef. This is my opinion. like the smoke tube boiler, we have the tubes where the smoke is passing through and the water on the each side of the tube.
Okay.
And also these two chambers of the, the waters also are connected with pipe, so the water is like it will act like also water tube. So I think that's why
Yeah, for
we
the
call
smoke
it.
tubes, we had studied that right in the beginning. Okay, let me find it where it is. Yep, this is the one. This is a very rough diagram, but as you rightly said, this is your furnace. Around the furnace, we have water tubes. So this part of it is the water tube. These are the risers. These are the downcomers. This is your bottom header, and this is your steam drum. From the steam drum, you have saturated steam going off to various services. But from your furnace, the smoke is passing through these bigger diameter tubes, smoke tubes, and going off to the funnel. And in these bigger diameter smoke tubes, what they have put is these are called pin tubes or sun rod tubes. That is the speciality of this design. So this part of it is a smoke tube. This part water tube, this part smoke tube. So this one is more of a hybrid, bit of both, and that is what increases the efficiency of this boiler. Okay, good answer, Souvenirs. What about the rest of you gentlemen? Any other questions? Yes, Michael.
Good afternoon, Chief.
Good afternoon to you.
I have one question about this smoke tube boiler and water tube boiler difference.
Please, yeah.
The smoke tube boiler are having less efficient composition. That day, Abraham was asking on the lecture, he was asking you, but I'm not satisfied with the answer. That's why if you have more, maybe now you can clarify more. This is about the smoke tube boiler difference. Point 3.
The smoke tube boiler itself, I'm not talking about the burner. The smoke tube boiler itself, the burner in a smoke tube boiler and a water tube boiler could be the same. But the entire efficiency, entire efficiency of a smoke tube boiler is less as compared to a water tube boiler. The amount of fuel that we are burning, let's say both the burners are the same. The amount of fuel that we are burning in the smoke tube and the water tube, for the amount of fuel that we burn in a water tube, the production will be much higher because of the design of the boiler. So efficiency of a water tube boiler is more than that of a smoke tube.
Yeah, but it says efficiency composition. I don't know why. It say on the point.
Where is that? No,
it talk about composition. It's less efficient composition.
No, it's not less efficient combustion. It's less efficient boiler. Maybe that's a mistype, which we can correct. The combustion, we can have the same burner in both the boilers, but the boiler itself, the smoke tube boiler itself, is less efficient as compared to a water tube. So that would be a mistype. It's not the combustion; it's the boiler, entire boiler itself.
Okay. That's why I'm confused a little bit.
I'm glad you brought it up. Then that means we have to correct it. I shall correct it here also, and you can correct it in your handout. It's not the combustion is the same. Yeah, the two people have raised their hands. The names are not coming. Who raised their hand?
Chief May, Walde.
Yeah, go ahead. Go ahead, Walde.
For this question, the highlight asking the smoke tube and water tubes. I think the difference is the surface area which is conducting to transfer heat. when it's smoke tubes and water tube, it will be big difference. That's why the efficiency also difference.
Exactly. It's because of the design of the boiler. In a water tube boiler, the surface area and the heat transfer is much better as compared to a smoke tube boiler. It is not the combustion. The combustion can be the same, but
Yes, the heat transfer area will be different, much different. So that's why it will be more better.
correct. And also the volume of water which is carried in a water tube boiler is less. So it evaporates, the rate of evaporation is also higher. Yes, Tesfahun.
Chief, I have one question on
Please.
the boiler system. I've been working before that on boiler. It's exhaust tube boiler, but for the auxiliary burner, it is water tube. But when the engine is running, it is exhaust tube boiler. So this kind of boiler, what will be the name of this one? I mean, can we call it exhaust tube boiler or water tube boiler?
Are you talking about a composite boiler?
Yes, I'm talking about the composite boiler.
Okay, in your composite boiler, one second. We had so was it something like this? Was it something like this?
I think so. When the auxiliary is working.
When the auxiliary is working, you mean when you are in port?
When the auxiliary is working, when the auxiliary burner is working, it's water tube. The water is passing through the tube. But when the engine is running, it's the water is on the outside surface of the tube.
When the engine is running, the smoke passes, the water is inside the tube, and what did he say?
When the engine is running,
okay,
the smoke is passing through the tube.
Smoke is passing through the tubes. Okay.
Yeah, so this is exhaust tube boiler. But when the auxiliary burner is working, the water is passing through the water tube. It's separate. The tubes are not working for common. It's separate tubes. Yeah.
In the same boiler shell, you have different areas where one part is water tube and the other part is smoke tube.
The smoke tube. Yeah, yeah.
Okay, that is also like a hybrid composite boiler.
Yeah, it seems like that, but I don't know what name can be given to this kind of boiler.
Yeah, just like the example which I was showing you earlier. There is one part is water tube, other that Albog Sundot boiler, the example which we were looking at earlier. There also one part is water tube, the other part is smoke tube. So that is also like you could say that is also more like a hybrid boiler. It's a bit of both. Yes, somebody raised his hand. Is that Bolde? Somebody had raised his hand. Who is that? Bolde?
Not now. This is the previous one. I already take out.
Oh, okay. Right. Any other questions, gentlemen? Yes, Sophonius.
Okay,
Sophonius, you raised your hand?
Yes, Chair. Can we go back to the hybrid boiler? I want to ask some question on that.
Hybrid, the first one which I showed you, this one.
Yes. Here, if we have a boiler which is only the the top part, if we don't have the lower part, I mean the water tube side,
If
can
we
we call this
did
top?
not have this,
Yeah.
the
Can
bottom,
we call this also like a hybrid because we have a water tube kind of construction?
no, what we, if you see my, where my pointer is, these are smoke tubes. These are not water tubes. The smoke is passing. Hang on a minute. No, yeah, the smoke is, yeah,
Because
but
the smoke is passing on the sides of these tubes.
on the sides of
And
the tube, and the water is inside the tube. But where would your furnace be in that case?
yeah, the furnace will be like this, but it will be refractory material, not chamber. It will be only chamber. I mean, the water will not be circulating around the furnace.
Mm-hmm. Yeah,
So the smoke will be passing in between these big pipes, but also the water is passing between the smoke. So can we call this like also a hybrid?
yeah, there will still be hybrid because this part is a smoke tube. So it is, the smoke is passing through the tube, but inside the smoke tube again you have a water tube. But that kind of boiler will not work very well because how will your convection current be set up? But yes, for the sake of our discussion, yes, that could also be a hybrid.
Okay, thank you.
That is one of the main reasons why your smoke tube boilers are not as efficient as water tube boilers. The convection currents which are set up in a smoke tube boiler are not very good. Whereas in a water tube boiler, the convection currents and therefore the heating is much better than a smoke tube boiler, and therefore the efficiency of a water tube boiler is much higher. Once you have a good circulation due to convection current, the water heats up that much faster for the same amount of fuel that is being burnt. Any other questions? Yes. Yes, El Michael.
Okay, Chief. One more question about this boiler tube plugging.
Yeah. Okay.
Normally, this plug must be supplied from supplier, yes, special plug. We are not manufacturing on board because we don't material property. When temperature rise, this property may be lose. Because last time we were speaking that we can manufacture on this machine and we can plug.
Yeah.
I was confused because we cannot use it.
Normally, when you have a new ship, yes, it is supplied by the maker. But when your ship is, say, 15 years old, that time maybe all those plugs are used up, and then you have a number of that was just a practical solution which I was giving. I have done it. When you're working on very old ships, you can have number of tubes which are leaking, and then you go and look for the plugs, and the plugs aren't there, or the number of plugs which we have on board, they are not enough. So then we have to fabricate on board. And since your boiler shell and the tubes are made of normal carbon steel, so your mild steel plug will do very well. It works because
So we are just take mild steel and we manufacture and use. Huh?
Yeah, you take a MS rod.
Can make like that.
From a MS rod, you can make a plug. Okay, let me show you some photographs. I have some photographs here. Just a minute. I'm just trying to find that slide. So this is how one would plug a leaking water tube in a water tube boiler. And on your right hand side, can you see this these photographs? On your right hand side, you would have in a smoke tube boiler.
Yes, Chief, we can see.
On a smoke tube, this is what I was going to, like I said, in the next class regarding this tube repair. The amount of information that we discussed, I was not very uh, satisfied. So I wanted to discuss something more on this in the next class. But anyway, since you brought it up, so I was going to show you these photographs in the next class. This is a water tube that has been plugged. So this plug, it can be made of MS because you see the diameter. If you take the coefficient of expansion, it is not that we are taking two very, very dissimilar material. The boiler tube is also a carbon steel, this thing, and the rod that can be made of MS. So coefficient of expansion is pretty similar, and that too for a very small diameter. The diameter of this thing will be maybe 3 or 4 centimeters. So how much of expansion can we have in just 3 or 4 centimeters? I mean, how much of difference in expansion can we have in 3 or 4 centimeters? And here you can see they have not only hammered the tube in for the sake of safety, they have also welded all around. And here also you can see they have welded all around. Does that answer the question?
Yes, Chief. Okay, thank you.
Yes, Tesfaun.
Sir, on the drawing that you show us about the plugging.
The photograph.
Yeah,
or
the photograph.
or this drawing.
No, the previous one.
The photograph.
Yeah, the photograph.
Yeah.
On the photograph, on the plugging, I mean that we are plugging on the top of the water tube, yeah?
Yeah, top
This
and
one.
bottom.
Where both, we are plugging in both direction.
Yeah, you have to plug from the top and the bottom. If you don't plug, if you're only plugging from the top, the water is still coming in from the bottom, and the tube, presumably somewhere in the middle, it is leaking. So we have to stop that leak. No? So you have to plug from the top and the bottom.
Okay, yeah. Just I want to ask this one, if we are plugging only from one side or from both sides?
No. Hey, plugging only from one side will not have any effect.
Okay.
I mean, it will continue to leak the same way it was leaking before. So it has to be plugged from both sides. Yes, gentlemen. 2 participants' names are not being given. Melasi. Yes, Melasi.
Yes, Chief, thank you.
Yeah, go ahead, please.
Chief, in the steam atomized burners.
Steam atomized burners.
Yeah, in this burner, just we are using steam.
Yes.
And usually in the combustion, there is sulfur from the fuel and sulfur dioxide as well. When we are injecting steam, it's just water and will not have this acidic corrosion in the components.
Yeah, if you remember, the quantity of the steam was just 2% that of the fuel. In these modern smoke tube, not smoke tube, this normal steam jet burners, the quantity of the steam required is only 2% that of the fuel. So the amount of, one sec, let me go and find that.
Sir, you are coming broken. Can you check your connection?
My connection is okay. The internet is broken. Can you see this? Hello.
Yes, we can see. Yes, yes, Chief.
So what does it say? The amount of steam which is being used is less than 2% of the oil consumption at peak loads, right? So the amount of steam which is being given in is very, very little. And anyway, once the steam goes into the out from the burner, and due to the very high temperature in the furnace, the steam immediately that becomes superheated. So there is no question of any SOx, I mean sulfur dioxide, etc., mixing and forming sulfuric acid. If that was the question. Hello, were you able to hear me?
Yeah, we can hear you. I think he's out. His internet maybe.
Yes, yes, we can hear you.
Okay. So does that answer the question?
Yes, sir, it's okay.
Any other questions? Yes, gentlemen. Any other questions? Right, one sec. Let me go back to safety valves. There was a question regarding feathering of safety valves, if I recall correctly. Yes. There was a question earlier that what happens if this starts feathering? One of you had asked us this question earlier. Can you recall? I'm not sure. I cannot recall who was it, but the question was a pretty interesting one. It's a pretty nice question. This is a bore relay safety valve, and the question was that what happens if this part, the control valve, that starts feathering? The main safety valve that is being pushed into place by the steam pressure only, in addition to the main spring valve. The purpose of the main spring valve is just to keep the main valve shut when the boiler pressure is zero. That means the boiler is laid up or something. But once the boiler starts firing and the pressure in the boiler, the main steam valve is pushed shut due to the steam pressure. But what happens if this starts feathering? If this starts feathering, that means spring tension is gone. And if this starts feathering, you will immediately come to know that it is feathering because you will find steam escaping from these vents and these ports. Whereas if you're in a normal boiler, if your main steam stop valve, main relief valve, that starts feathering, it is possible that you will not come to know, because from here it is going straight to the funnel. And unless somebody is keeping a watch on the funnel, which is not very practical most of the time, unless somebody is keeping a watch right on the top of the funnel, we may not come to know that our main steam stop valve is feathering. And of course, if the main steam stop valve is chattering and feathering over a period of time, from the boiler water, all the deposits that will start depositing over here. And then when we want the safety valve to actually operate, because of the deposits, it may not operate properly at all. But here, yes, if we find that this is feathering, that means we'll come to know, because we'll find steam escaping from these vents, from these ports. We know that the valve spring has lost its tension, so that means we have to renew the valve spring. Similar parallel I can draw. Let's say, for example, your main engine cylinder head safety valve, cylinder head relief valve. What is preventing the relief valve from feathering? Your cylinder head relief valve, just the spring. So if at some point when the ship has become old, you find that every time the cylinder is firing, the relief valve also tends to feather or lift slightly. That means the spring of the relief valve has lost its tension, and you have to replace the spring. I'm not sure who had asked that question at that time, but yeah, that was a nice one. Any further questions, gentlemen? Any other questions on what we have studied, or even a little outside? I'll try my best to answer. And like I said, if I don't know the answer, I'll find out and let you know. But yeah, go ahead and ask if you have a question. Are you able to hear me?
Yes, Chief, we can hear you.
Okay. Yes, Hail Selassie. Okay.
Chief, I have one question.
Yeah, please.
For the port state, is there any limitation that the port state should not ask? Did they have any limitation? For example, can the port state ask to inspect the boiler inside the water side? That can lead the ship to delay or something?
Volde has asked, what is net stack temperature? Net. What do you mean net? I didn't understand the question. Excellency, could you repeat your question again? Okay.
Okay, can you hear me?
Yeah, okay. Go ahead, please.
Yeah, my question was for the fourth state, when they come and they inspect the boiler, they ask some questions. Is there any limitation? Is that possible they can ask whatever they like? For example, that can lead the ship to be delayed. For example, if they can ask to inspect the boiler from water side, from inside.
No. No. The normally, unless they have very good reason to, port state will never interfere with the operation of a ship. So that means inspecting the boiler from the water side. That means they're interfering with the operation of a ship. That is not in their interest also. So they will never want to see, yes, what kind of fuel you are burning in your boiler. That they will be very interested to see whether it has got the right sulfur content, etc., etc. And then all your technical files for the boiler and for the main engine, etc., whatever you're maintaining on board, those records they can see as far as pollution and safety is concerned. But no, they cannot ask you to show them the water side or the smoke side of your boiler. No. Does that answer your question?
Yes, thank you very much.
Okay. There is another question. How is the safety valve adjusted after overhauling or after survey? So if you recall, we were discussing this, that normally say for a survey, or we take out the safety valve from place, we dismantle it completely, we clean it up, we lap the valve and the valve seat together and any other parts that need to be lapped, and then we assemble everything, and then in the workshop, in the engine room workshop itself, we with a water pump, we can do a rough setting of the safety valve, whatever we were giving the example of the boiler, the operational pressure, max design pressure of the boiler being 15 bar. So we are, so say 15.45. So we set since there are two safety valves, we set one at 15.2 and the other one we can set at 15.3 or 15.4, wherever. But the rough setting we can do in the workshop itself. The idea and the reason why I had said that, so that when you finally put the safety valve back in place and then you've raised the steam, you've taken water in the boiler, you've raised the steam, and then you in front of your surveyor, that time we should not land up with any surprises that this gasket is leaking and that we have forgotten to assemble this and etc. Basically, in the workshop itself, you've done a rough setting. Once you fitted the safety valve back in place on the boiler is warmed up now, the setting will change marginally. So the fine tuning, the final setting, you do it in front of the surveyor. That means the spring tension. The safety valve is basically working on spring tension. So the final adjustment of the spring tension, how much compression you are giving to the spring, that final setting we do in front of the surveyor when the boiler is completely warmed up. So all we are doing is setting up the spring tension. That means we are the spring has got the spindle. Let me find a diagram. It will be easier to explain on a diagram. I'm not adjusting the work here. Of course, this diagram, this kind of unit we will only have in the manufacturer's place. We may not be on board. On board, we just use a normal bucket and a pump which can raise the pressure to what we want. Okay, we come to the high lift safety valve. Okay, here you have your compression nut. This is your spindle. This is this dotted line. That is your spring where it says here, and you compress the spring using this compression nut. The compression nut is pushing down on this compression ring, and the spring pre-tension is being increased. Basically, what we are doing is this top spring carrier, we are pushing it down against the bottom spring carrier. And what is the bottom spring carrier doing? That is pushing down against this slot, slot, against this collar on the spindle, and thus the spindle is pushing down the valve lid against the valve seat. So all we are doing is increasing or decreasing by setting of the safety valve. All we are doing is increasing or decreasing the tension. And then once we achieve the spring tension with this compression nut, with another lock nut, we lock it in place so that it does not get disturbed. Or if there is a split pin arrangement or something, we put a split pin so that the setting does not get disturbed in the future. Right, Wolde, you had a question.
Yes, sir. Thank you. On the boiler combustion process, the ship draft can affect the combustion process. Have an effect on the combustion process.
Say that again. On the boiler combustion process,
the ship draft
draft
have an effect, yeah, or trim or least.
No. That
doesn't affect the combustion process.
No, it should not have any. No, it will not have any effect on the combustion of the boiler burner. That is completely independent of the ship's draft, right? Now, why do you feel there may be a connection?
Yeah, I read some articles about this boilers, and they say this high exhaust temperature, one of the reasons for high exhaust temperature for boiler is excessive draft. They say excessive draft, but I didn't understand. Excess draft, yeah.
No, I have not come across this.
Okay, Chief.
Are they talking about a propulsion type of boiler, like for a steam turbine? Yes, gentlemen.
Come again, sir.
Yeah, go ahead,
what
please.
You say?
No, are they talking about a propulsion boiler? That means the one which you use for powering the main steam turbine, which is powering that propeller.
Yes.
Main propulsion boiler.
Yes.
Okay, so maybe in a main propulsion boiler, the steam turbine will require more power if the draft is more, and if the draft is more, the boiler also needs to produce more steam. So yes, there we could have some implications, but on our kind of ships, like normal tankers and bulk carriers, etc., no, the boiler is completely independent. If it is a main propulsion boiler, yes, like if your draft increases too much, there will be a lot of strain coming on the main engine also, normal IC engine. So by that reasoning, yes, they could be more, let's say, pressure on the boiler to produce more steam, and therefore the boiler's efficiency could be affected. Yes, Sophonias, you raised your hand.
Yes, Jeff. I think this draft is not a draft of the ship. Maybe this is draft air, like what we say, draft
Air,
fan.
air draft. Oh, you're talking about forced
Ah,
draft. FD fan.
yes, FD fan. I think that is the reason, because if we have more air, then that kind of problem might happen.
No, he said draft of the ship. I thought he said draft of the ship.
I mean, maybe he misunderstands the draft
Okay.
for the air and the draft for the ship.
Oh, okay. Yeah, if your FD fan is not performing well, obviously your combustion will get affected. Yeah, will get badly affected. If it is giving too much air, that means your secondary flame is cooling down. If it is giving too little air, that means the proper combustion is not taking place. So either way.
Chief, sorry.
Yeah, go ahead, please.
If this draft means this is the draft which is blowing the air to the boiler, if it is excessive, how it can be high temperature will be the effect of high temperature?
No, if it is excessive, it will cool down. I said it will cool down the secondary flame. It will not be high temperature.
But my question is, there is high temperature from the boiler exhaust line, but the reason is, they say the reason is excessive draft
of the ship.
Yes.
Excessive draft of the ship. Yeah, that is what I understood also. That you said excessive draft of the ship. Yeah, if the ship's draft is excessive, that may obviously the power required to move the ship is also excessive, and the steam requirement is excessive. And if your steam requirement is excessive, that means you'll have to burn more fuel. So your stack temperature, that is your uptake temperature, can increase. The same thing like our normal IC main engine getting overloaded. If the ship's draft is excessive or there's too much adverse current or adverse wind, a main engine also can get overloaded, and then we can have high exhaust temperature and high uptake temperature also. The same thing applies here in case of a main propulsion steam turbine. Yes, gentlemen.
Chief, I have one question about this boiler survey.
Okay. Who's speaking? Your name is not
normally about boiler survey.
coming. And I asked who's speaking because your name is not coming here.
I'm Haile Michael.
Oh, okay. Okay, Haile Michael, go ahead.
So normally when we make survey, surveyor is not coming on board due to inconvenient port or something, and he's sending the list what to do, and we're making that job when we're taking picture about that and we send him back, so he will approve, and he will extend the boiler survey time.
Okay.
I have this experience. So normally, for how long this like this survey, how long it's serving this certificate he approve, how long it will use for the ship? Is like normal or have some limitation?
In a normal cycle, because this kind of a situation I have not come across earlier, because your IAX, you must be familiar with IAX from your classification chapter. So IAC rules, they say that any pressure vessel has to be surveyed by any pressure vessel, any bearings, etc., has to be surveyed directly by the class surveyor, and it cannot be I mean, the chief engineer, he cannot do the surveyor's job for pressure vessels. But as you say, in your case, maybe it was a one-off case. But for how long? I don't think he will give a full term. Your full term is normally for boiler survey to survey is normally 3 years. And what was the size of the boiler?
Let me check.
If you just tell me the evaporation rate, I'll be able to guess the size.
Was oil fire was 4,000 kilogram per hour. It was his capacity. oil fire site.
For the steam output was 4,000 kg per hour.
Per hour, yeah. But for this is for firing.
Okay.
We was so for this we was because we was on board, so we was coming from company some email to make some list on safety valve, on blow down valve, some things, and we take picture and we send it back.
Mm-hmm.
But we was not sure for how long he will extend his survey time. I was curious.
No, I'm also not sure because this is a pretty unusual situation. It is not a very normal situation, but maybe he must have discussed something with the company office, and they must have come to some understanding that okay, we will give an extension for till the next port or till the next dry dock or whatever.
Okay.
Any other questions? Yeah, go ahead, please.
Yes, Chief, thank you. Can you go through?
Hello. Hello.
Yes, Chief. Can you hear me? Yes, Chief.
Yeah, go ahead.
Can you go into a little bit deep how the boiler survey can be made? I want to know more, Chief.
You want to know more about a boiler survey?
Yes, Chief.
Okay. Yeah, normal boiler survey. It is as we had discussed. It is normally 2.5 years plus minus 6 months. But all class they give boiler survey periodicity as okay. Let me. I'm sure most of you would have seen a class listing, but let me show one to you. One second. I'm just trying to find that. It does not seem to be on this computer. I thought if it was there, I would have shown it to you. So anyway, normally all your IX class. Of course, you obviously know what is IX class. All the major classification societies, they form a group which is called IACS. As per IX rules, the periodicity of your boiler survey is normally 3 years, 2 plus minus 6 months, but it is never minus. It's usually always plus, and they give the periodicity, the frequency as 3 years. If you must have seen your class listing on board, depending on which class your vessel was classed with, whether ABS or Lloyd's or DNV, etc., etc. All of them they give 3 years. Now, once you are coming to this this time of 3 years, so that has to coincide with either the vessel's dry docking, which is normally every 5 years. The actual dry docking. I'm not talking about the in-water survey. the periodicity of the dry docking is normally 30 months. But at 30, yes, David, can I finish this? I'll get back to you. So
Yes, go ahead.
yeah, I'll just answer, go through this boiler survey, then I'll get back to you, David. Where was I? Okay, now your periodicity of your dry docking, so-called dry docking, is about 30 months. So, but in the first 30 months, we never do the ship's dry docking, we do an in-water survey. After that, after 5 years, that is 60 months, we do a proper dry docking, in which we take the ship to a proper yard and do it. Now this boiler survey, obviously for boiler survey, the vessel has to be taken out of service. We cannot do the boiler survey on a running vessel. Normally the boiler survey will be both on the exhaust boiler and the auxiliary boiler, auxiliary or main boiler, as the case may be. So we time it along with the in-water survey, that is at 30 months or at 60 months with the dry docking, even though the boiler may not be due. But we still try to do it, because otherwise taking the ship out of service just to do a boiler survey is not economical at all. Okay, well, when we do a boiler survey, what is the first thing we do? We cool it down, then we have to drain out the water. Once we drain out the water, we have to take out all the mountings. Once we take out all the mountings, we clean all the mountings, lap all the valves that we require to be lapped. Then we display them for the surveyor to come and see, including the mainstream soft valve and your safety valve and your boiler gauge glasses also. So everything is overhauled and kept nicely. And then once the surveyor has seen all this, then we start assembling all this back. And this job can be either done by the ship staff, or if the ship is in a shipyard, we could also subcontract it or give this job to the shipyard people. And then once everything is back in place, we have done a rough setting of the safety valve. We put the safety valve back in place, take water in the boiler, check that everything is okay, no leaks, etc. No leaks in the furnace also. And inside the furnace, of course, any fire clay or fire brick repair, we have to repair that before we show the boiler to the surveyor. And once we have done all that, then we start firing the boiler after taking the water, and we do the setting of the safety valve. Now, is there any specific question that you had regarding this boiler survey? Hello?
No, that's all, Chief. Thank you.
Okay, David, you had a question.
No, that was my question. Thank you, Chief.
Oh, okay. Any further questions? Yes, El Michael.
On the book, it says that boiler survey for ship up to 8 years, it should be every 2 years.
No,
After 8 years.
No. When I was teaching this,
On the book.
I had said that please correct it in your book. What is written in the book is incorrect. Please correct it. I had sent you the. One sec. That is incorrect.
Okay.
And boiler survey does not depend on the age of the ship. It is 3 years fixed. Whether it is for main boiler or propulsion boiler. Main boiler or propulsion boiler or auxiliary boiler.
Okay.
Let me find that slide. Yes. I had shown you this slide and I had asked you to correct it in your book.
Okay.
This is the IAX rule at present. Is that clear?
Yes, Chief, I am looking at it. Yes.
Okay. What you pointed out, Hill Michael, that when I read that initially, it puzzled me also. But then I have got hello. I've got some contacts in various classification societies. I checked with each and every one of them, and they all came back with the same thing. I checked with Lloyd's, ABS, and DNVGL. They all said the same thing.
Okay.
So this is the present
Okay,
regulation.
that's right.
Hello?
Okay, thank you, Chief. Okay. Okay, thank you, Chief. Okay.
Okay. Any other questions, gentlemen? As I said, it need not be about boilers. In case you want to ask about anything else, please go ahead. Yes, Hill Michael.
About this thermal fluid,
Yeah.
the pressure is 1 bar, yes, normally max. So at 1 bar we reach the required temperature.
1 second.
But
1 second. Let me bring up that. Yeah.
yes, example, if we look synthetic oil,
Yeah, synthetic fluid.
it's 1 bar. Just at 1 bar we reach the required 300 temperature something.
Yeah. Even your white
But
mineral
this
oil,
fluid,
at 1 bar, it is reaching 300.
okay.
And
But
the
this 1 bar pressure enough cycle inside the system, or we have another system to pressurize the fluid.
No,
This
no, no.
enough to recycle and back.
Yeah, it should be enough. It should be enough to keep the thing, keep the fluid moving. If you recall in the class, I had said that if your pump is somewhere at the bottom and this synthetic fluid, this thermal oil is also going to your exhaust boiler, then we should factor in the head of if the exhaust boiler is very high up, then we should factor in the amount of head or amount of discharge pressure which the pump should develop. So the system has to be designed accordingly. So that then, if the exhaust boiler, the difference in height between the exhaust boiler and the pump is a lot, then the pressure will need to be more. But for the sake of our discussion, yes, at 1 bar pressure, we can achieve this temperature. But what you're talking about is system design.
Because I don't think this fluid will go inside tank and come back to the boiler with this pressure. So I was confused. Or we need to develop this pressure more.
No, you don't think what?
This fluid with 1 bar going to inside tank, example, fuel oil tank, is bottom, double bottom tank, yes. And he will back to the two boiler with 1 bar pressure.
Okay, that you're talking about. See, in this graph, he's talking about the properties of the various kinds of thermal oils. That at 1 bar pressure it can achieve so much, but how much pressure you actually need, that depends on your system design. That depends on your vessel. So wow, yeah, like you said, yes, 1 bar pressure may not be enough to push the thermal fluid inside your fuel oil storage tank and back out again. So you will require more pressure. But here in this graph, we are talking about the properties of these fluids.
Okay, thank you, Chief. Okay.
And what you're talking about is a system design, that the pumping pressure or the throughput of your pump will vary upon the design of your system on board.
Yes.
Any further questions, gentlemen? Majority of the questions have been asked by only a few people. What about the others? They are keeping very, very quiet. Come on, gentlemen, step up. Any further questions? Otherwise, we can stop for today. But any further questions, I'll be most happy to answer. And if not, have a very good weekend. Have a good evening.
Okay, thank you. See you, Chief.
Thank you. Have a good evening.
Thank you,
Thank you.
Chief. Have a good evening.
Okay, Chief. Have a good weekend.
You too. You too. And have a good
Stay
evening.
home, stay safe.
You and you. Same to you.
Okay, thank you.
Thank you, Chief.
Thank you.
Thank you. Bye-bye.
Bye.